Hey QED coders, this is Michael. Alright, making sure that we are live. Yes, we are. Hi, how you doing? I'm going to be doing some Jinaga.net coding today. So Jinaga.net is an immutable runtime. Immutable runtimes are something I discuss in the book. So if you would like to come join me on Discord, we can talk about the book, we can talk about immutable architecture, we can talk about immutable runtimes, and you can follow along as we try to build. Now, I think this is the third immutable runtime. So the first one was correspondence written for .NET. The second is Jinaga.js, and the third now, Jinaga.net. Although calling it the third runtime might be a little bit too much because it's the companion to Jinaga.js. So Jinaga.net, Jinaga.js, they both talk in terms of immutable facts, and they're just for different target platforms, and they work together. At least that's the intent. So the actual practice right now is I'm just getting Jinaga.net off the ground. But Jinaga.js is something that you can use right now. You can get information on that at jinaga.com. So, a quick overview before we jump into code. What does it do? What is an immutable runtime? So, you can think of an ORM as something that that binds your code, or your classes in memory, your objects in memory, to a relational store. So now consider if that relational store was immutable. So instead of updating and deleting rows in a database, all you could do is insert. All you could do is create things. Then what would that ORM look like? You would end up querying over those historical facts and then projecting them into something that looked like it was mutating. So you would be able to take immutable historical facts and project them into objects. So that's kind of step one, and that's really the stage at which Jinaga.net currently resides. Beyond that, it's going to replace your API, so you won't have to make a REST call in order to save and load and update and delete data on the server. You're just going to create these immutable facts. Sorry about my cat making a big old noise there. Be able to create these immutable facts, and they will be shared up with the server and shared with other people who are connected to the same server. And that's where Jinaga.js and Jinaga.net meet up, is that they can both participate in that one immutable runtime. So they're both connected to the server. You've got a web application using Jinaga.js. You've got maybe a mobile experience using Jinaga.net. And anything that somebody does on one creates an immutable fact sent to the server, shared with the other. And the idea is that that sharing is transparent to you. All that you have to do is express the facts and their projections. And then the rest is figured out. So all of that's possible because of some really awesome mathematics called CRDTs, conflict-free replicated data types. And so I would say Jinaga, in general, is a general-purpose CRDT. And so it enables all of these capabilities by using the mathematics of CRDTs, and that's precisely the set of patterns that you'll see in the Art of Immutable Architecture. But the question now becomes, what do those patterns look like in code? So to answer that question, I'm going to do a quick screen share here. So let's grab the stream, and we'll grab Visual Studio, Jinaga.net. There we are. Alright, so is my video updating? Okay, good. Yes. Yeah, in the past, that video window right there was giving us trouble. At any rate, here we are in Jinaga.net. So Jinaga.net, everything is an immutable fact. So we store information in terms of facts. These things right here, flight, airline day, these are facts. What do they look like? Well, since we're in .NET, they look like records. A record is a new kind of thing in .NET. It can actually be expressed just like this. Doesn't even need to have a body. It's kind of cool. So simplify all those things. So a record in .NET is an immutable class. So you can think of this record declaration as creating a class, and this is now the constructor signature of that class. Records have only one constructor. And in addition to those constructor methods, the record also declares a couple of properties. So you've got airline and date as now properties of this class. And those are read-only properties. They can only be initialized in the constructor. And so that's why we say that records are immutable classes. And so that makes it the perfect way to express immutable facts in Jinaga. So this model that we're looking at here, it starts right up here with an airline. So an airline has a particular identifier. So you'll see in a lot of my tests, I'm using an airline with the identifier IA. I'm not even sure what IA stands for, but Immutable Airlines, I think, actually is what anyway. So if you think about American Airlines, AA, Southwest, WN for some reason. Must be some historical reason behind that. So every airline has an identifier, and if anybody is talking about the airline with the identifier AA, they're talking about American Airlines. So they're always talking about the same thing. And so that's the same thing about facts, is that anytime somebody is talking about new airline IA, they're talking about the same fact. So you don't have to have some auto-incrementing ID inside of your database. You don't have to have any other kind of identity. That is the identity, the value of the fact. So we've got this airline, Immutable Airlines, and an airline day now is a particular airline on a particular date. So we're using today for these tests, mostly because the date doesn't actually matter for the test to work properly. But that airline day is a successor fact to the airline. So that means that an airline can have multiple airline days. Each one is going to be on a different date. So every time you start a brand new date, you capture a brand new airline day to go along with it. So that's an example of something that I call a period in the book. It's a pattern for subdividing your data according to a clock. And so here we're using the discrete clock of a day, and now we're saying I'm going to have a flight. So a flight is a particular airline day and a particular flight number. So if you were to take a flight, here we're taking flight IA 4272. Well, if you were to take that flight on a different day, it would really be a different flight, but it would have the same airline identifier and flight number. So it's really this entire object here that distinguishes a specific event, a specific flight. So it takes that day in order to differentiate it. So we've organized things in this way so that I can check to see all of the flights that are available on a particular day. And that's going to help me to run all sorts of historical queries. So if I'm looking to book a flight in the future, I can query for flights available on those future dates that I'm looking for. Or if I have captured a reservation and a flight that occurred in the past, then I've got that information there. And that's all the flight. Here we have a condition associated with this flight. Is this flight canceled? The flight is canceled if, for facts of type flight cancellation, there exists any cancellation for this flight. Okay, does that kind of make sense? You can think about this as entity framework. You can think about this as a query over a DB set. So this would be the equivalent of your DB context, and of type is kind of the equivalent of your DB set. So we're looking for cancellations, which are in the set of flight cancellations. And now we're looking specifically for those where the cancellation flight is this flight. And now we select those cancellations, and if any exist, the flight is canceled. So that's how you can read this. So we can use this is canceled condition inside of a query. So right here, I am looking for, given flight cancellations, I'm looking for the flight. That's not a very interesting one. This one is... Okay, I don't have one that's very interesting. Let's go ahead and make one that's interesting. So I want to query a particular airline day for the flights that are not canceled. Let's go ahead and write that test. So I'm going to create a new test, and I'm using XUnit, and XUnit uses fact in order to define a test. So don't get confused. Fact here doesn't mean fact in Jinaga. It means a test in XUnit. So I've got an async inc task. Can query based on not exists, or we'll just say based on condition. Okay, so first of all, we're going to populate the object that we're talking about. So I'm going to want the airline day, and a flight. Well, let's go ahead and pop those in there. All right, so there's my flight for today, and now I want to book some, I want to have multiple flights, some that are canceled, some that are not. So we'll call this cancel flight. So I'm going to say await j.fact, so that puts that fact into Jinaga. I'm going to have a new flight for this same airline day, and now it's going to be a different flight number, 5555. So how do I know that that's a canceled flight? Well, that's because I have a j.fact, which is a new flight cancellation for that flight. So because that flight cancellation exists, and I have to give it a new date time now. So because that cancellation exists, that flight is canceled. So if I were to query for the flights that are not canceled, I should only get this one. Got it? So let's write that query. I'm going to say, here's my specification. Given an airline day, so I'm going to start with that fact. Then I'm going to match from my airline day. And I get my collection of facts in here so that I can start to query against them. So what am I going to match? I want to find the flights. So from flight in facts of type flight. Okay, so I've got those flights. Now I want to get the flights that are a part of this airline day. So where flight airline day equals that parameter right there. I'll start with this. Select the flight. Okay, so that should give me all of the flights for a particular airline day. So I'm not yet taking the cancellation into effect. But what I want this this test to give me is that when I query for the flights, so I'm going to do a j.query starting at airline day, and I'm going to query based on this specification. Given that, now I'm going to get back an immutable list of flights. Everything's immutable. Jinaga.net uses the Immutable Collections to remind you of that, and so that you can take advantage of all the opportunities that immutability gives you. Like, for example, structural sharing and thread safety and all sorts of good stuff. So I've got some flights. What I want to eventually end up with is the flight, just this one flight right here. So flights should contain single, which should be equivalent to this flight right here. Okay, so right now this test is going to fail because I'm getting back all of the flights. What I ultimately want is just the ones that are not canceled. But let's go ahead and run the test and let's see it fail. Make sure that it fails for the right reason. Okay, Test Explorer. Here we go. Let's focus on that test. All right. So I expected flights to contain a single item, but I found these two items. It's kind of hard to see what those actually are. So I'm going to launch a new VS Code window, because VS Code does a really good job of this. All right. I've just copied that that text, which is really just a strangely formatted object, but I'm going to pretend that it's JSON. Come on. Here we go. So we've got a new file. Let's pretend that this is JSON. And that's a good start. It's not perfect, but at least it gives me multiple lines. So we have two flights. Here's a flight, here's a flight. Okay. They are both for the airline day, which is that particular airline IA, the date. Oh yeah, you can see that daytime now was Central Time, and it converted it to UTC. All dates in Jinaga are UTC. But yeah, that makes it interesting. The domain for a day is really just that date right there. So we'd probably want to change the domain so that it doesn't use date time. At any rate, You can see that's the same value. Flight number 4247, flight number 5555. So those are the two objects that are inside of that collection. And according to my test, I wanted just one. So how am I going to get just one object into that collection? This is where, in addition to this where clause joining this airline, or this flight to this airline day, I also want where not flight dot is canceled. So now I just want the flights that are not canceled. So this is how you would express a conditional query. I happen to know that this is not going to work, but let's go ahead and give it a shot anyway. Let's see precisely why it doesn't work. It doesn't work because I have not implemented execution based on conditionals. Cool. So we're seeing behind the scenes, we're seeing the memory store inside of Jinaga.net that we're using in order to run all of these tests. So let me take this opportunity to go ahead and implement this memory store condition, or this execution based on conditions. So we are talking about not a successor step or a predecessor step, but instead a conditional step. So this set right here, that's the set of immutable facts that are coming into this step. And then I'm going to execute a condition on each one of those steps. So here is the conditional. Well, what is a conditional? Let's go ahead and look at it. So we've got some steps, and we check to see when I finally get to the outcome, does that exist? So I need to be able to grab access to both of these things. Let's go ahead and expose those as properties. Okay, so I've got those properties. So now I'm going to run these steps, and then I'm going to test whether it exists. So exists is a Boolean. It's going to give me back true, false. True means I'm testing for existence. False means I'm testing for absence. Okay, so I'm going to execute that conditional step. Let's generate that method. Let's put this in the right order here. Okay, so you can see here I'm executing these predecessor and successor steps. Here I'm just walking a graph. I'm walking along the edges, where the edges have a particular role and a successor type and a predecessor type. So those are just walking along those edges and grabbing the next set of fact references. In this case, I want to return this set filtered by this condition. So let's start off with set where. So we've got a fact reference coming in, and we want to test this condition. So what is this condition? It means execute a sequence of steps, which probably walks a graph. And then if that gives you back any results, then and exists, and you're testing for exists, then it's true. If it doesn't give you back any results and you're testing for exists, it's false. not exists, it's the opposite. So how about we do this? XOR. Oh goodness, XOR, is that a caret? I have forgotten what XOR is in C#. That's so funny. I never use it. Let's see. I wish I had some pair programmers on here. Okay, I don't want the bitwise, I want the logical. So I am looking for logical XOR. Yes, it is the caret. Okay, perfect. Alright. So that means that it's going to be true if they are not the same. Alright, so that's kind of weird logic. Let's make this a little bit easier to read. Even though I just went ahead and looked that up, let's make this easier to read. Alright, so I want to execute the steps. I'm just going to go ahead and put this inside of some braces so I can, first of all, execute the steps. Okay, how about, let's see, as any. So what does it mean to execute the steps? So we can see here we are executing a single step. I'm using that right here when I execute a sequence of steps from this starting fact reference. Sounds like exactly what I'm after. So execute steps starting from fact reference for this sequence of steps. And I just check to see, do you have any? Okay, so that's going to give me back one Boolean. And then, if I'm looking for, let's just go ahead and write it out longhand and we'll refactor this down. See how tight we can make it before it stops making sense. If I'm looking for existence and has any, that's true. Else, if I'm not looking for existence, and it does not have any, then that's true. Okay, so that's what we're looking at here. So we've got these sets where this is true. It's asking for an immutable list, so .to immutable list will give you back what you're expecting. And now we've got an implementation. So that should make this pass. Let's make sure. Alright, we have a passing test. We can execute conditional steps. It was that easy. That's awesome. Okay, now let's clean this up, see how far we can go before it stops making sense. So I'm going to, let's see, merge with the next. Okay. Yeah. Convert to a conditional expression. Yeah. So we're looking for exists and has any. Let's rename this, and it might make more sense. Want any. How about that? If we want any, and we have some, it's true. If we don't want any, and we don't have some, it's true. Yeah. So the alternative there is not want any, caret has any, which makes absolutely no sense to any human. So this makes a bit more sense. It has the unfortunate side effect that I have to put that into a variable because I have to use it twice. Whereas the caret XOR, I wouldn't have to put it into a variable, and I could turn that into an expression. But I'll live with that. That makes a bit more sense. And the test still passes. And indeed, all of the tests pass. Yay. Okay. So we can execute successor steps. I'm sorry, we can execute conditional steps in the in-memory stream, which means we can now do this query. So given an airline on a particular day and 2 flights, and the cancellation of that second flight. When I try to match flights on that day that are not canceled, I get back only a single flight equivalent to that one. That's the test. And a good test it is. Let's commit that. All right. So this is what the experience of programming in Jinaga is going to look like. Every time the user makes a change, you record a fact. You just await j.fact and capture what they just did. Capture the decision they just made. And then when you want to display something to the user, you write a specification. This is looking for facts in a certain shape. So related to one another in a certain way, where some things exist, some things don't exist, and you then filter those down and give them just the information that they are looking for. Right now, we have j.query, which runs that specification in real time. So it just run it, give me back the results, and then I can do whatever I want with those results. That's the way that we're used to doing entity framework code, that kind of thing. Wouldn't it be cool, though? Wouldn't it be really awesome if instead of querying and getting back the results, you could watch those results? And then every time something was added to the results, you would get notified. Every time something was removed from the results, like for example when a flight is canceled, it gets removed from the results, even though the facts are still there. The facts are immutable. The projection of those facts, those get removed. Those can change. So anytime something is removed from the results, you get notified. And anytime one of the results changes, you get notified. So that would then allow you to bind that to a user interface. So for example, in a Xamarin application on a mobile device, you could then bind this to XAML. And so these specifications will basically be the foundation of your view models. So user takes an action, pushes a button, that view model then intercepts that event and sends a fact. And then data bind all of your properties to specifications, and when the specification produces new results, the property changes, updates the user interface. That's the programming model that I'm going for with Jinaga.net. The programming model in Jinaga.js is pretty similar. So in Jinaga.js, I bind to React. React is the primary user interface framework that Jinaga.js targets. And so whenever something happens and there's a new fact and it changes a projection, then that changes the properties that it uses to render React components, and it updates the user interface. So I'm going for the same kind of idea, but just working within the .NET ecosystem, MVVM rather than Model View Update. Okay. So there is another kind of query that I want to go ahead and write the test for, because I think this test is going to pass now. Let's take a look at passengers. So I've got a passenger. Let me go ahead and simplify that. I don't need a body until I want to put conditions in it or something like that. So here's a passenger. And oh, by the way, this fact type right here, skylane.passenger, that's the same type that's going to be expressed in any kind of Jinaga runtime, so Jinaga.js, so that Jinaga.net and Jinaga.js can talk to each other. They're both talking about passengers using that type name. That way, this type name can be whatever you want it to be in .NET, and something completely different in JavaScript. Let it live within your code base as it should within that ecosystem, and use this in order to bring the two together. At any rate, so we've got a passenger. If I take a look over here, I see there's also a passenger name. So a passenger name is a fact about a passenger, has a particular string value, and it knows the prior passenger names. So that means we can use this to represent a passenger changing their name. So maybe they go onto the website and they get into the profile portion of the application, type in a new value, hit save. That creates a new passenger name, where prior is the array containing just the previous one. And so that creates this chain where prior is pointing back in time. It's an array for two reasons. One, the first one doesn't have any priors, so that array would be empty. If that were the only reason, then a nullable type would be just fine. But that's not the only reason. A passenger might be using the website, or they might be using the mobile app. They might be using some other kind of client. Maybe they have sent an email to somebody who's going to change their name on their behalf. So lots of different ways that you can get a passenger name into the system. Those things might not know about each other in real time. So they might be on the website editing their name, and somebody else is updating it on the back end. And so they have sent their passenger name here. The back end has sent the passenger name there. We get these two passenger name facts with different values. How do we know which one is right? The answer is we don't. All we know is that they are both leaves. Neither one knows about the other, but they know about the prior ones, and so those have been replaced, but everything that has not been replaced is a candidate current value. So we used an array so that we could capture all of those candidate current values and bring them back together. This is how we can resolve conflicts. Think about a git merge. A git commit is a historical fact pointing back to the prior commit. But a merge commit can have multiple priors. And that's how you can take multiple concurrent histories and merge them back into a single history. Exactly the same pattern going on here. I should be able to express that pattern now in code. Let's give it a shot. Alright, so I can query for current value of mutable property. And by mutable, I mean it's following the mutable property pattern based on immutable facts. So let's start talking about the passenger. So I'm going to have a new passenger, and it's a passenger for an airline. So let's go ahead and bring our airline into play here. And it's for a particular user, so let's talk about the user. New user, and the user has a public key. So rather than generating a real one, there we go. We're going to fake it out. But In a real application, of course, that would be a real public key, which now gives you the ability to encrypt things specifically for that user and have that user sign things so that you know that that information came from them. So encrypting and signing facts, that's going to be part of the framework. It's going to help you with that. It doesn't do that right now, though. So passenger, yeah. So now I want to create a name. So, first name, how about initial name? It's the first one that we're creating. I want to do await j.fact on this. Otherwise, it's just a record hanging out there. It's not part of the model. Now it's part of the model. Okay, so I'm going to create a new passenger name for this passenger. And so the initial name, we'll call him Joe. And now we need a passenger name array. Now, eventually, this is what you can do in JavaScript. Yeah, that's not going to work right now. Eventually, you should be able to do something like this. Actually, can you do that now? I think you can't quite do that now. But I think that is a C# language feature that's coming soon. Type inference on array initialization. That'll make that job a little bit easier in the future, but for right now, we'll have to specify the type. So that's my initial name, Joe, with no priors. It's just the initial name for that passenger. So then I should be able to say updated name. So this is a new passenger name for that passenger, Joseph. And so this passenger name array contains the initial name. Okay, so the update refers back to the initial. So we create that link, that series of changes. Now I want to know what is their current name. So I'm going to say current names. We'll see why in a second. Is equal to, so wait, j.query. So starting at passenger, I'm going to say, given a passenger, I want to match okay. Now I am looking for passenger names. So from name in facts of type passenger name, I want those names that are for this particular passenger, where name.passenger is equal to the passenger parameter. Okay, so those are all the names for this parameter. I just want the ones that are current. So I can say where not nay. That would be funny if the opposite of any was nay. All right, so we're not from next in facts of type passenger name, where next dot prior contains name. Select next. Okay, and that right there tells me, nope, this isn't going to work yet. That's not yet implemented. But getting so close. Okay, so I'm looking for passenger names for this passenger where there does not exist a next passenger name having prior contained this name. So nothing has superseded this name. Then I'm going to select name. And this gives me back the current names. So this is an immutable list of passenger name. So why is this current names instead of current name? Can't there be only one? Nope. There can be more than one because concurrency. Because you can capture passenger names from different systems at the same time without them knowing about each other. And so you can have lots of passenger names that are not contained within the prior collection of a different one. They haven't been superseded. Now I could take this and wrap it inside of a conditional just like this. Ends up being the same thing. But for right now, we should be able to give this a shot. So I should end up with current names should contain single, because there's only one that is current, and that's Joseph. Which dot value should be Joseph. Okay, so I'll end up with an array, an immutable list, to be precise, of current passenger names with one element in it, and the value of that element is Joseph. That's what I should end up with. But when I run this test, I'm going to get another not implemented exception. And that's because right here, this is, oh, okay. Even when I'm just trying to serialize this thing, I'm having some trouble. Interesting. So predecessor, oh, that, okay. No, yeah. It's just because I haven't implemented predecessor multiple in serialization. I can get past this one real quick. Case predecessor multiple. And so what I'm trying to do is create a list of edges. So I should be able to return multiple dot references. So for each reference, I'm going to select a new edge. And it's going to have, oh, I use the constructor. So the constructor is predecessor, role, successor. So reference. Yep, I've got, okay, so I'm going for, here's the successor. Right, so the references here are predecessors. These are predecessor references, of course. So predecessor is reference dot, oh, it's just reference, yeah. And then the role is multiple has a role, and the successor is a fact. So I'm going to give you the successor references. Okay, that'll get us past this implementation detail. And let's go on to the next not implemented exception. And this one should be a bit more difficult to implement. All right, so what are we in here? Well, we're inside of a parser of expressions. Oh my goodness. So we're looking for unary expressions and method call expressions and unary expressions of method call expressions and all sorts of craziness. So this gets into the the deep down details of being able to parse this expression tree right here. So this is the first time that I used the contains method call, and so it's complaining, here's a new method, it's an extension method. What's an extension method on? On enumerable. Right, so here we are. We know that this is a method call. It's not on queryable, so the declaring type is type of enumerable, and then we're going to have to determine what that means. But that is a problem for another day. So that's getting into all the nice little nitty-gritty details of implementing Jinaga.net. So my plan, my hope, my ambition for Jinaga.net is that we'll be able to store things in a memory a memory store and run tests like this. We'll be able to detect changes and update things from that in-memory store, and then we'll be able to take that to different storage mechanisms like SQLite and what else would be running on the client? Maybe Postgres on the client. Don't know, but SQLite definitely is going to be one of the targets. And then also on the server, I should be able to write this code on the server and have it do some kind of business logic up there as well. Maybe that could be your web backend, and it could be serving up a Razor front end. Maybe this code can live inside of your Blazor application, and you've got your backend and your front end collaborating with immutable facts. I mean, those are all the use cases that I'm trying to target. But baby steps, one thing at a time. And so we have just taken a nice little baby step here. I'm going to get this committed, get that pushed up, and keep on working on Jinaga.net. Until next week, have a great day, have a great week, and I will see you on the next Immutable Book Club /Jinaga Stand-Up. Cheers.